All right, so I'm going to be pretty clear with this one. The big formula for determinants is fairly gross. It's got a couple of uses, mostly improving other results. So we're not going to spend a lot of time working on this in this course. But if you go on to further mathematics courses, you might see this. What I want to get from it right now is I just want to kind of present it, and then I'm going to kind of tease our next idea. So the big formula is this kind of nasty thing. It's the determinant of a matrix A is going to be the sum over all of the permutations of the determinant of the permutation matrix times A1 alpha, A2 beta, A3, oh god, I don't know what the third Greek letter is. All right, forget it. Dot, 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 to a let's say n and omega. Uh, so we're just going through the alphabet here, right? And p is the permutation that puts alpha in the first column, beta in the second, on and on until we get to omega in the end. Don't worry if this feels a little weird. So this is the permutation of the columns. Okay, so what the f does that mean? All right, here's what the f that means. That means I've got a matrix A that looks like A11, A12, A21, and A22, right? Classic 2 by 2 matrix. All right, the permutations, like all two of the permutations, are either you have one and then you have two, and the other one is you have two first and then you have one, right? There's only two factorial ways to arrange two things. So here are the two factorial ways, right? What this means is that I can write down the determinant of my matrix A is A11 times A22, right? That's alpha's 1, beta's 2. That's here what I've got. And then I need to, the determinant of that one is positive. One of the quick ways to figure out whether a determinant of a permutation matrix is positive or negative is it's positive if it's been an even number of exchanges, it's negative if it's been an odd number of exchanges. So because 1, 2 is a 0 exchange, that's a positive permutation. And 2, 1 is a 1 exchange, so that one's a negative permutation. So we're going to be subtracting A12 and A21. And you might notice this is really just like AKA AD minus BC, right? Like we know that one already, so this isn't probably news to us. It is good that it agrees with our usual. So here's a slightly worse case. And this is just the 3 by 3 case. So I've got my matrix A that's given by A11, A12, A13, A21, A22, A23, A31, A32, and A33, right? Okay, so I'm looking for all of the permutations for this. There are three things to rearrange, right? One, two, and three. So those are the permutations of one, two, and three. Right. So if I'm listing my permutations, right. The first one is leave one, two, and three alone. That's a positive permutation. Now, I know that if I switch three and two, I'm going to get one, three, two. That's going to be a negative permutation. Now, if I switch, so I'm going to go back to this guy. I'm going to switch 1 and 2. That's going to also be a negative permutation. Right? That's 2, 1, 3. And I'm looking for 6 of these. Right? Because there's 3 things to rearrange. So there's 3 factorial of these. Let's see. We can swap to 2, 1, 3. So to get to 2, 1, 3, I essentially made this permutation, right? Oops, that's wrong. Sorry, I already had that permutation written down. 2, 3, 1. So I start with my first permutation, right? I switch 2 and 3 and then switch 1 and third, the 1 and third spot. So that's a double switch, that's an even permutation. And then I know I'm going to get a 3, 1, 2 is another one. That's also a double switch permutation. And then I've got one more that's negative. That's the 3, 2, 1 permutation. That's where I just switch the first and third things. So these are my 6 permutations, right? Now I'm going to write down the formula for the determinant of my matrix A. So the determinant of A is going to be, it's got to be A1, 1, A2, 2, A3, 3. So that's this first one here. That's this guy. Now my next one's going to be, I'm going to subtract, and I'm going to put this guy down. So that's A1, 1, A2, 3, and A2, 2. Remember, the first numbers are always going to go, oops, like I said, the first numbers are all going to go 1, 2, 3. And the second numbers are going to be read out of the permutation. So that one there is this guy here. All right, let's go grab us some more colors. So here's another one. So that's going to be another minus permutation. Whoopsie daisy. That's going to be another minus permutation, right? And that's going to be A1, 2, A2, 1, A3, 3. Then we're going to do this guy here. So that's going to be an adding. And I'm adding A1, 2, A2, 3, A3, 1. So that's this guy here got a squiggle. That guy there got a fat orange underline. Let's give this guy a fat pink underline. That's going to be another one that we're adding. And that's going to be A1, 3, A2, 1, A2, 3, 2. And then we're going to have one last one here, which we're going to give a big fat red underline to. Throw that here. And that's going to be a minus A1, 3, A2, 2, A3, 1. Okay, now here's the trick for this guy. I'm going to go ahead and group these according to the way I wrote them down. Oh, except I wrote these two down in kind of the wrong order. F it. All right, so I'm going to group these. Oh, I didn't write them down in the wrong order. It's fine. It's all fine. All right, so here's my deal. These guys both start with an A11, right? So I'm going to write that down as A11. And then here I've got a little 2x2 matrix, right? Forget the 2x2 matrix for a second. I got A22 times A33 minus A23, A32. Then I got minus, and I'm going to factor out an A12 here. And then I'm going to be left with A21, A33 minus A23, A31. Notice how those feel the same but kind of backwards? All right, last one we're going to have plus A13, and then we're going to have times a A21, A32 minus A22, A31. Okay, I feel like there's a trick here. That I had 2, 3 as the second two numbers here, and then I have 3, 2 as the second two numbers there. Then I have 1, 3, then 3, 1. I have 1, 2, then 2, 1. Where have I seen that pattern before? I saw that pattern with the first one I did, where I had 1, 2, and then 2, 1. So that feels like the permutation of the determinant of a smaller matrix. If I wrote this out, that's A11 times the determinant of a little matrix A22, A33. Oops, not that way. Let's write this correctly. So A33, right? That's this product. And then we're subtracting the other product. So that's A23, A32. And then I got here a minus A12. The determinant of this little guy is I've got an A21 up here. I've got an A33 down here. And then I've got a A23 here and an A31 here. And then I've got a plus, I've got an A13, determinant of A21, A32, A22, and A31. And then there's kind of a cool thing you can notice. Here's the cool thing. I noticed that if I look at the little matrices that I'm left with, right? So like, let's look at this one. So where's that matrix appear up here? I noticed that A11, right? So I'm going to actually make some copies of this thing. I'm going to do a little slick trick because I'm teaching with this computer in front of me. Oh God. Why wouldn't you copy and paste nice? Because I'm using a pen? Okay, let's try this. Lasso tool. Oops, I missed. Take 2 on the lasso tool. Okay, let's copy that thing. Let's paste that down here. Why are you not pasting nicely? Well, that sucks. All right, I figured it out. So here on this first one, right, I've got A12, or A11, that's this guy. And then I've got this little matrix here. So this little matrix here is actually this guy right here. So essentially what we did is we crossed out everything in the row and column except for the A11, and then we took this little matrix and calculated its determinant. In this other one here, I've got that same thought. I've got A12 here. That's this guy here. And then I've crossed out, oops, almost went wrong. I've crossed out the column and the rest of the row that's in. And then my little matrix is this dude here and that dude there. And then in my kind of third case here, I've got A13, that's this entry here. We've crossed out the column and row that A13 is in, and I've got this little matrix here that's the one that shows up right there. See that? So this guy and this guy make up that matrix, and my little blue one here, that guy right there. So this is a teaser for the cofactor formula. So the cofactor formula is going to be the method we use by hand. Thanks for watching. Much appreciated. If you find this a little bit confusing, that's kind of okay. It is fairly hard to wrap your head around all the permutations. Do be aware that as this gets bigger, the number of permutations gets a lot bigger, right? So I went from 2 to 6. The next one's ought to be 4 factorial, right? So that's 24 options. So I'm probably not going to do a big formula for 24 or for a 4x4 matrix, because I'm going to have to write down 24 permutations and be sure that I've got their signs right. And that just takes a lot by hand. So don't feel bad if this feels undoable by hand. It's not a great thing to do by hand generally.